Hello, today we are doing class 9 physics motion in one dimension, and this is the second video for this chapter. And today we'll do graphical representation of linear motion. Okay, so linear motion, we have already learned the definition in our first video that when a body is moving in a straight line path, then the motion of a body is said to be in a linear motion. Okay, today we'll try to understand the same linear motion of a body with the help of the graph. We have three graphs to understand this linear motion. First one is your displacement time graph, the second one is your velocity time graph, and third one is your acceleration time graph. Okay, since when the body is moving in a straight path, okay, in a particular direction, at that time the direction of the body will not change. Okay, when the direction of the body will not change, displacement and the distance will be the same. So when the body is moving in a straight path line, then at that time displacement time graph and the distance time graph are same. Similarly, velocity time graph and the speed time graph will be same. Okay, today first we will do displacement time graph. Okay, so when we are talking about the graph, so graph means we have the two axes, one we take as x axis and the other we take as y axis. Okay, this x and y are the two variables. In the displacement time graph, we will take time along x axis and displacement along y axis. So the point of intersection of these two lines, if you consider O, in graph we call this origin. Here we can consider as starting point. And we have to know that displacement time graph will represent the velocity. Okay, so that means whatever slope we find in the displacement time graph, that is the velocity of the moving body, because we know that velocity is the ratio of displacement and time. Displacement time graph will give us the velocity of the moving body. So the slope we'll get from the displacement time graph is the velocity. Okay, and we have to note down when the body is moving away from the starting point, this will represent the positive slope. Okay, so going away this direction, that means it is going away from the starting point, is your positive slope. And if suppose the body is coming towards the starting point, this is the starting point, this line represents the starting points. Okay, so if it is coming towards the starting point, this considered as the negative slope. Clear? Okay, so first we will do the displacement time graph for a stationary object. Okay, what is stationary? Stationary means rest. Okay, so we know the definition of the rest. What is the definition of the rest? A body is said to be at rest when it does not change its position with respect to its surroundings. Okay, we'll just consider here the term rest. Okay, so rest is what? So if the object is there, if I am standing here, okay, and okay, so let's take one example. I am standing here, I am at rest now. So if I am at rest, I will not change my position, I will not move from this position. But what about the time? Time will also be at rest. No, time will be moving on its own flow. It will be running. Every passing second, my position will not change. Okay, so that means when we draw the displacement time graph for a stationary object, what will happen? The object will not move, but the time will be moving. Understood? Time will be passing. If this represents the time and this represents the displacement. Okay, see here y axis represents displacement and the x axis represent time. So if this is the starting point O, or this point, both displacement and the time is 0. So initially if we keep the object here at position 25 meter, okay, and we see the time 1 second, 2 second, 3 second, 4 second, 5 second. So now if we see that the body is stationary, the body is not moving at all. Okay, at that time when the time is 1 second, the body will be, the time is 0 second, the body will be at 25 meter distance. When the time is 1 second, okay, at that time the body will still be at 25 meter. When it is 2 second, the body will be still at 25. 3 second, the same. 4 second, the same. 5 second, the same. Now if we join these points, what we'll get? We'll get a straight line, and which is parallel to the x-axis. That means which is parallel to the time axis, or we call this is a time line. This x-axis is considered as the time line. So then we can say that displacement time graph of a stationary object is a straight line parallel to the time axis. Next we'll do displacement time graph with a uniform velocity. So we know the term uniform velocity when the body covers equal distance in equal interval of time in a particular direction, then the velocity of the body is said to be in a uniform velocity. When the body is moving with a uniform velocity, body will cover equal displacement in equal interval of time. So the displacement time graph here represents the straight line, represents a straight line which is inclined to the x-axis. Here this line represents the velocity of a moving body, or uniform velocity. Here the body will cover equal distance in equal interval of time. In 1 second, okay, here body will cover 10 meter. So this is displacement in meter and time in second. Suppose in the 2 seconds the displacement of the body will be here 20. In 3 seconds the displacement of the body here will be 30. In 4 seconds displacement of the body will be here 40. In 5 seconds the displacement will be 50 meter. So from here it is clear that at every second the body is covering equal distance in a particular direction. That means the body is covering equal displacement. Every 1 second the displacement of the body is here 10 meter. So this we can represent in the table. If you have to write this in the table, the motion of the body, let's take time in second and displacement in meter. So when the body started at point 0, when the time is 0, the displacement will be 0. When the time is 1 second, the displacement will be a 10. 2 second, displacement will be a 20. In 3 second, displacement is a 30. In 4 second, displacement is a 40. In 5 second, displacement will be a 50 meter. This is the tabular form of a moving body with a uniform velocity. Here now, if you have to know the velocity of the moving body, if we say that a car is moving with a uniform velocity and the car covers in 1 second, car covers 10 meter, 2 seconds 20, 3 seconds 30, 4, 40 and 5 seconds 50 meter. So now we have to find the velocity of a moving body or velocity of a car. Suppose if this is a OP, this represents OP. So if you have to determine the velocity of the body, from any 2 points we can determine. We can determine with O and P also, or we can take any 2 points here. Okay, so let's take this point as A and this point as B. From these 2 points, first we'll try. So if you have to represent the velocity, or if you have to find the velocity, that means we have to find the slope of this line. Okay, so here in order to find the velocity, what we have to do, we have to draw a horizontal line from point A and vertical line from point B. So here this will be 90 degree because horizontal and the vertical. So that means this will take as C. So here BC is perpendicular and CA. From the graph, velocity of a moving body is equals to slope of line OP. Here we have to find the slope of line OP. So in order to find the slope of the line, we can take any 2 points. We can take this point and this point also, this point and this point also, this point and this point. Any 2 points we have to consider. So here slope we are taking 2 points. AB, your slope will be BC upon AC. Okay, BC upon AC. This is nothing. BC is the displacement, that means total displacement from point A to B, and AC is the total time taken to cover A to B. Okay, so this is a total displacement upon total time. Displacement upon time is a velocity. We know that velocity is equals to displacement upon time. Clear? So now we have to find this. So how much is the displacement when the body is moving from A to B? Initially the body was at A. So when body was at A, what was the displacement of the body at A? From 0 to here, the body was at 20 meter mark. Let's consider this as S1. And when the body reaches at point B, and the displacement of the body is here is 40 meter. Let's take this as S2. Total displacement we have to find from these 2 points will be 40 minus 20. This is meter. Okay, meter. And if you have to find how much time is taken, so that means when the body reached at point A, the time is 2 seconds. So this consider as T1. And when the body reaches at point B, the time 4 seconds, 2 seconds and the 4 seconds. But we just have to find the total time taken by the body to reach point B from point A. What is the total time? This is the total time. 4 minus 2. So this time will be a 4 minus 2 second. This is equals to 40 minus 20 is a 20 meter divided by 2 second. This is equals to 10 meter per second. 2 1 are 2, 2 10 are 20. The velocity of a moving body here is 10 meter per second. So we can take any other point also. If you consider from these 2 points, slope of line OP, we have to draw a horizontal line from O, and we have to draw a vertical line from P. Wherever it will be, it will form a right angle triangle. And from these 2 points P, let's consider this as Q. Okay, if you consider PQ here, PQ is the displacement. Here we write this will be a PQ upon OQ. O, at O the body is at 0 displacement, and at P the displacement of the body is 50 meters. Total distance covered will be how much? 50 minus 0. At starting point time is 0. When the body reaches at point P, the time at that time is 5 seconds. So this will be a 5 minus 0. This will be give you 50 upon 5. This is a meter, this is a second, this will be a 10 meter per second. If you have to find the velocity of the body, we have to find 2 points on the slope which is inclined to x axis. With that slope, we can easily find the velocity of the moving body. So we can take any 2 points. From those 2 points towards the x-axis we have to draw the horizontal line, and from the y-axis we have to draw the vertical line. From there we can easily find the velocity of the moving body. To understand this clearly, let's take one example for the displacement time graph with a uniform velocity. One more example. So here we will take that if a car is moving with a uniform velocity, along x-axis we will take time, and along y-axis we will take displacement. Okay, displacement in meter and time in second. This is your time, this is our displacement. The intersection of the two axes we consider as starting point. In the starting point, both displacement and the time is 0, and if the car is moving with a uniform velocity, if it is moving with a uniform velocity, displacement time graph is a straight line inclined to x-axis. That means the car will cover equal displacement in equal interval of time. Suppose we take this as 2 seconds. At 2 seconds, the distance covered by a car, let's take this as 20 meter. In 4 seconds, distance covered by the car will be 40 meter. In 6 seconds, distance covered by a car will be a 60 meter. And this position is our A. This position we consider as A. This is your initial position O, and this position is your A. Now we have to find the velocity of a car. So here from the graph, velocity of a car is equals to slope of a line. What is the slope? OA. OA. From O, let's draw a horizontal line, and from A we'll draw a vertical line. They'll meet at point B. Okay, so here it will form a right angle B. Now slope of the line OA will be the displacement. That means velocity only. Velocity is equals to displacement upon time. AB, this will be AB upon OB. AB is the displacement here. How much is the displacement? So here we just have to find the displacement covered by the body moving from O to A. Okay, from O to A, what is the displacement? O to A, at position A, the final displacement of the body is 60. A car is 60 meter. Okay, initially it was at 0 meter. So that means difference of these two displacement will give you the total displacement from O to A. So this will be a 60 minus 0. And here, if you have to find the time, it started from 0 second, and when it reaches at point A, the time taken by the car was 6 seconds. So final time is a 6 seconds, initial time is a 0 second. From here, 60 upon 6, 6 1 are 6, 6 10 are 60, this is a meter, this is a second, is equals to 10 meter per second. This is the velocity of the car. Clear? So this is very, very simple. We can take any 2 points. Whatever 2 points we consider, from those points we have to draw a horizontal line and a vertical line. They'll meet at a point. We consider that as one point, and from there we can find the slope of a given line, and the slope of a given line in a displacement time graph is a velocity. So in this way we can find the velocity of any moving body with a uniform velocity. One more thing, if the body is moving with a uniform velocity, suppose x-axis, this is your y-axis, this is your time, this is your displacement. Okay, so now see here, I'll make the two bodies. So they are starting from this here. This is the path followed by a body A, moving body A, and this is a path followed by a moving body B. Here it is a straight line. This means displacement time graph here is a straight line which is inclined in the x-axis in both the cases. Now the question will come, whose velocity is more? The velocity of A or the velocity of B? We just have to know one thing here. If you see the graph also, we can see here slope of line A is less than slope of line B. From here we can clearly see that angle formed by AOX is less than the angle formed by BOX, or here angle BOX, okay, is greater than angle AOX. From this angle we will know that which slope is more. So here slope of slope of line OA is less than the slope of line OB. So that means the slope of line OB is greater than the slope of line OA. Now we have to know one point, that greater the slope, higher the velocity. From here we can easily say that whose velocity is more? The velocity of B is more. Why? Because line OB forms the greater slope than that of the line OA. Now we will try to understand the positive and negative slopes from displacement time graph. Okay, suppose we have a graph here. Here this is your, okay, I'll make it little longer. This is your x-axis and this is your y-axis. This is your time in second. This is displacement in meter. This direction. This is going this direction. This is the initial position where the two axes intersect. Let's take one example. If we throw a ball on a plane surface, the ball will bounces back. If you have to draw the graph of the ball when we throw on a plane surface and how it will bounce back. This is the starting point. From here we are throwing a ball. It will strike a plane surface and it will return here. So here in this position, if we consider this as 1 second, 2 second and 3 second, 4 second, 5 second, and this is a 6 second. In 1 second, ball will cover say this is a 1 meter, and the 2 seconds here 2 meter, 4 meter, and 3 seconds it will cover 6 meter. Again in like another 5th second it is coming down, it is dropping down here, and 4 second and the 5 second the position of the ball will be this. So this is the initial position of the ball, and A is the position of a plane surface. This is our plane surface here. Okay, the ball will strike and it will returns and reaches to the starting point at 6 second. Okay, starting point we consider as B. This is the starting point at 6 second. Now we have to find the positive slope and the negative slope. Earlier we have discussed that when the body is moving away from the starting point, then the slope is positive. If the slope is negative, then the body is coming towards the starting point. So here we have to find the slope. So let's find the slope. Slope of OA, that is positive slope. Why? Because in here OA, what is happening? The ball is going away, or the object is going away from the starting point. The slope is positive, is equals to, how do you find the slope? We find the slope with 2 points. Point this one and point these 2 points. From these 2 points we can find the slope. So here, from here we will draw the perpendicular line, and from here draw the horizontal line. So this consider as P. From the slope of OA will be a AP upon OP. This is equals to AP is how much distance? AP from here to here. So what is the distance, total distance? 6 meter. This is a 6 meter, and how much time is taken in the 6 meter? Initially it was at 0 meter. So this will be a 6 meter minus 0, and the time will be a 3 seconds minus 0 seconds. This will be a 6 by 3. 3 1 are 3, 3 2 are 6 is equals to 2 meter per second. The ball is dropped with a velocity of 2 meter per second. For negative slope, we can find slope of AB. If we find the slope of AB, we will get the negative slope. See here. So we can explain also how we determine this negative also. So here the ball is moving from wall to the starting point. It is coming from here to here. Okay, that means from the wall to the starting point. Okay, so when it will move here, the slope of AB will be how much? Again, APB. This is the horizontal line we will draw here, and this is the vertical line. So it meets at point P. Okay, so that means here slope of AB will be a AP upon PB. The movement of the ball is from this point to this point. It's moving from this point to this point. Initially the distance was how much? 6 meter. Okay, finally it will reaches to the distance how much? 0 meter. So this will be the final will be 0 minus 6 divided by, so how much time it is taking? So earlier the time was how much? 3 seconds. Okay, it started at 3 seconds, and when it reaches the point B, the time was 6 seconds. So that means here final time is a 6, initial time is a 3 seconds. So this will be a minus 6 divided by 3, 3 1 are 3, 3 2 are 6 is equals to minus 2 meter per second. The velocity is here negative. This represents the negative slope. Here ball is going towards the starting point. So from here it is very clear when the body is moving away from the point. This is away. When the body is moving away from the starting point, then the slope is considered to be a positive slope. Positive slope. And when the body is moving towards the starting point, towards the starting point, then the slope formed will be the negative slope. Now we will do displacement time graph with variable velocity. We know when the body is not covering equal distance in equal interval of time in a particular direction, then the velocity of a body is said to be in a variable velocity. I have a table for a moving body in each interval of time. You can see here, when the time is 0, displacement is 0. When the time is 1 second, displacement is 7 meter. 2 seconds 12 meter, 3 seconds 20 meter, 4 seconds 32 meter, 5 seconds 42 meter. From this table it is clear that the body is not covering equal distance in equal interval of time, and the body is moving in a same direction. That means the velocity of a body is considered to be in a variable velocity. And so this is your displacement, this direction, and this is your time, this direction, and displacement is in meter and time is in second. Okay, x-axis represents time, y-axis represents displacement. For variable velocity, displacement time graph is a curve. Okay, and in order to find the velocity of a body at any instant, we have to draw a tangent at any point in this curve. Okay, and the slope of that tangent will give you the velocity of a body at that particular time. If you have to know the velocity of a body at any instant, that will be given by the tangent. First we'll draw a tangent here at any point. Let's draw a tangent A, B, and here PQ is a curve which represents variable velocity for displacement time graph. Okay, if suppose we have to measure or calculate the velocity at this point, say M. Okay, if you have to know the velocity of point M, we have to find the slope of line AB, slope of the tangent AB, then we'll get the velocity of body at point M. From here, if you draw a horizontal line, where do you meet? You will meet here. This is the horizontal line. From here, we have to extend our horizontal line this side, and from here, if you draw a vertical line, let's take this as C. Okay, by knowing the slope of the tangent AB, we will get the velocity of the body at point P. Velocity of moving body at M. Slope of tangent AB. So here, in order to find the slope of the tangent AB, like in the earlier sum, we first have to know the displacement at this point. Okay, so this will be a change in displacement. Okay, our total displacement BC upon AC. In BC, how much is the displacement? Let's see here. If you draw a point from here, initial displacement is here, this point, at point A is 20, and the final displacement is 80, this point, from here to, from this point to this point. So here it will be 80 minus 20 divided by time. So time at point A is your 4 seconds, time at point B is your 8 seconds. This will be a 8 minus 4. This is a meter, this is a second. This will be how much? 80 minus 20 will be 60 divided by 8 minus 4 is a 4. This is meter, second. 4 1 are 4, 4 15 are 60. Therefore 15 meter per second. So now we got that the velocity of a body, moving body at point M is 15 meter per second. At any instant, if we have to find the velocity of a body, we have to draw a tangent, and finding the slope of that tangent, we will get the velocity of a body at that instant. So what we have understood, that for a displacement time graph, variable velocity is a curve. And if we have to know the velocity of a body at any instant, we have to draw a tangent at any point on this curve, and finding the slope of that tangent, we can find the velocity of a body at that instant. So far what we have done displacement time graph for a variable velocity. We have done displacement time graph with uniform velocity. We have done velocity time graph to find the positive and the negative slopes, and now this one, velocity time graph with the variable velocity. From here we can conclude that when a body is stationary, then the displacement time graph is a straight line parallel to the x-axis or the time line. And when the body is moving with a uniform velocity, displacement time graph is a straight line inclined to x-axis. And when the velocity is variable, or for a variable velocity, displacement time graph is a curve. We have also learned to find the velocity of a body when it is moving with a uniform velocity and or it is moving with a variable velocity. To find the slope of the line when the body is moving with a uniform velocity, that is, we have to take any 2 points, and when the body is moving with a variable velocity, we have to take 1 point on the curve and draw a tangent on that curve. By finding the slope of the tangent, we can find the velocity of a body at any instant. And we have also learned the slope is positive when the body is moving away from the starting point, and the slope is negative when the body is coming towards the starting point.